Want to quickly start with microservices. Okay, I want to start microservices between, if anything, that we required from Spring Boot, that also we look into it. Okay, so I'll give little bit background about this microservices. Okay, little bit background why we need and how it is advant- advantaging us in terms of development or in complete project scenario. Okay, we'll discuss about it. Yeah. Basically, before microservices, okay, if you are into any application development, if you are currently working, or basically if you know the applications, maybe you have done your academics, or if you are currently into a project which is monolithic or a single application. Old applications are monolithic applications. Before microservices, our application development is in monolithic. Yep. Yeah, yeah, we will see. Okay, I will add that. Just a minute. Just a minute. And again, resharing. I'll present you one pic that I have copied. Yeah, we will discuss AOP, transaction security, everything. Okay. Anyway, we are not going out of Spring Boot. We will do everything in Spring Boot only. We can apply everything. Okay. Yeah. So basically, earlier all the applications which we used to development, which we used to develop in monolithic architecture. Monolithic architecture is nothing but a single application for everything. Okay. For everything, for all the features, we used to maintain everything as a single application. If you see this left side part, monolithic one, we have UI here, business layer here, data access layer here, and database. All these are together here into a single application. If you observe microservices architecture, you can see one UI, but still this UI also we can separate it. If you see here, we have one UI, and coming to the backend part has been divided into multiple microservices. And a database also split it into multiple databases. In simple way, you can understand a big application breakdown into small pieces. Why we need to do this? What are the advantages we have with this? Will it really help? Is it not good idea to maintain an application as a monolithic instead of microservice? Okay, these are all questions we need to discuss here. Okay, basically the problem with monolithic architecture, the problem if you go with this monolithic architecture, right? Monolithic architecture. If you see any SDLC, okay, waterfall. Let's say I'll take one waterfall model SDLC, waterfall. In waterfall, what we do in waterfall model, we collect requirements first, requirements gathering. Let's say if it is a large application, we'll take one example, okay? For with monolithic architecture, we'll take one example how we will handle end-to-end application, okay? Product to management system. A product to management system or a warehouse management. Okay, let's include product management system is having modules like here I can create products, okay, managed products and manage multimedia of that products, manage users of the system, okay, and create e-commerce data and links. A lot of requirements I have here in this product management system, so I can create and manage my products and I can sell them into e-commerce. Okay, let's say if you are a seller in for one e-commerce, in any e-commerce application, if you observe, right, there will be many sellers, they used to sell their products. I'm a seller, so I want to manage my products via my product management system and I want to publish my products into e-commerce system to sell them. Okay, so I have a lot of electronics or other gadgets I have to sell them, so I'll create in my own product management system and later I'll sell them. Okay, this is the system I want to create. Let's say if it is having large number of requirements, okay, multiple requirements you have here and you want to develop it in a monolithic architecture. So I choose one SDLC model, software development lifecycle, to start with my application. When I choose SDLC waterfall, or you may go with Agile or anything, first thing that we do is requirements gathering. We will collect all the requirements. Okay, if you see SDLC in waterfall, what we do, we collect all the requirements first, requirements gathering, then we design the system for that requirements, then we go into development phase, thereafter we do testing, then deployment, and we will take it for the maintenance. Okay, yeah. So I need to do all these steps to deliver my application. So I want to design and deliver a product management system in waterfall. So in waterfall I need to do all these steps: requirements gathering, then once I collect requirements, the next step is design the system, design. Once designing is done, design means the architecture, you know all the use cases, everything. Like this is business requirement and this is going to be functional requirement, functional diagrams, or the architecture diagrams or database entity designing, everything will fall in here. Then we go for development, so we do coding, front end, back end, database, everything. Then once coding is done, we take it for testing. Once the testing is done, we try to deploy it. We will deploy it. So once everything goes well, and we manage it or we maintain it. maintain that application. Feature changes or any bugs if come in the feature, we will manage it. So if you take SDLC here for this product management system, consider this product management system is having 10 modules. 10 modules we have here in this product management system. And I want to develop this product management system in monolithic architecture, or you can say the old applications which we used to develop it in single project. Okay, one single project we create to maintain a number of modules, only one project for multiple modules. Okay, so as I have 10 modules here, I'm creating only one single application for that 10 modules. Okay, so here if you see how waterfall works, we need to collect all the requirements of 10 modules. We need to collect all the requirements. All requirements we need to collect for the 10 modules, or 10 modules requirements we need to collect. Let's say if it is going to take efforts of 3 months time. 3 months of time to collect the requirements. Yes, we need to spend 3 months time to collect the requirements. Then all 10 modules we need to include together and we need to design a system. We have to design a system which is including all 10 modules. For all 10 modules we need to design a system. A sophisticated system for all 10 modules we need to design. So we need to design a system for all 10 modules. Let's say again if it is going to take 3 more months of time. Okay, so 3 months of time for the collecting requirements. So this is how in olden days we used to develop applications in SDLC. First we used to spend a lot of time to collect the requirements. Daily we used to spend in calls with clients, and we used to do back and forth questions and answers, and we used to document all the requirements along with the BA, and later we convert that business requirements into functional requirements. Then we start designing the system. So once designing phase is done, then it will go to the development. All 10 modules maybe which is having high priority we start with, and then we go with low priority. But all team members used to work on the same code base, right? When it is a single application, though you have 10 team members or 20 team members, they used to work on the same modules, or parallelly we can work on different modules also, but we used to work on a single project. We used to work on a single project. Then once everything is done until completing these 10 modules, or if each module independent, if you can able to develop and deliver, you can deliver it so that testing people will get some work and they can start testing it. Let's say you implemented login module and one product creation module, and if it is okay to you to test it independently, you can deliver it so that they can test it. But altogether testing plan is given for 3 months, until unless you completing this 10 modules. Unless you completing these 10 modules, they can't take it for the testing, because all the integration testing need to be performed once you completed with all these 10 modules design. And let's say testing also taking 3 months of time, they need to spend 3 months of time and to test it. If there are any bugs, again they need to give it back to developers so they can fix it and they can deliver it back. Once testing also is done, if everything is good, then we can take it for deployment and maintenance. May not take time here, but this much time we need to spend before deployment. This much of time we need to spend to deliver the 10 modules. 3 months for requirements, 3 months for designing, 3 months for development, and 3 months for testing. But this practice will make wait this product owner or whoever wants this system. Okay, whoever wants this system, they need to wait for until this long time. Okay, 336 and 336 total 12 months, 1 year of time. And here and there, if they can have any issues, maybe they can take it to 1.5 year, 1 year or 1.5 year time. is going to take for this product management system until that 1 year or 1.5 year. My screen is visible, right? Until the next 1 year or 1.5 year, as a product owner, I can't able to see my system, the complete system. Okay, let's say here investment, I am investing on this application for this 10 modules, 10 crores. The end system I can't able to see next until 12 months. Until next 12 months, I can't able to see the end system. Though I am investing this much, until completing all these modules, I can't able to see my system. So just this is from the business point of view. If you see, this is from the business point of view. Parallelly, if you want to develop this application and if you want to deliver module by module, and if user wants to use it in monolithic, it is not possible. Until unless completing the complete system, we can't deliver it. Still you can deliver it, it will have patches. That is not good to use also. Later it might create unnecessary issues as well, integration issues and all. So now, instead of waiting this much long time from the business side, is there any better architecture do I have to design my system? Let's say I brought these requirements to some ABCD company, they proposed it. Okay, I taken this to ABCD company, as they are working in monolithic only, they proposed it. ABCD company proposed this waterfall SDLC, and they need this much time to deliver the product in monolithic. Same product, I'm taking it to some XYZ company. There they want to develop this in microservices architecture. In microservices architecture, I want to develop these 10 modules. I have same investment 10 crores, and I brought this requirement to some XYZ company, and they want to develop it in microservices. So if it is in microservices, what we can do? If it is in microservices, what we can do? Agile is the best. Agile is the best model to deliver this system, or best practice to deliver this system. Okay, Agile also will work on waterfall only, like small waterfalls we will use in Agile. Okay, for every sprint. So I have 10 modules here. I have 10 modules here for this product management system. So in Agile, we will have lot of sprints. We'll have lot of sprints. Okay. So initially we will keep all our requirements. All requirements we will create, and we will keep it into all requirements into backlog. We'll keep them into backlog, all requirements. Now in that all requirements, I have 10 modules requirement. 10 modules requirements I have here. All 10 modules requirements I have here in this backlog I created. Not fully, covered, but I created. I know what are all the requirements I have. Like I want to create products, I want to manage multimedia, I want to create users, I want to, manage users. I want to create e-commerce data, links, advertisements data, coupons and all. Everything I want to create. Very high level idea I have. I created them as a story, simple stories. Like we need products, or we want to manage products, something like that. A small write up I have in this backlogs for all the 10 modules. Now this XYZ company taken up this, and they want to deliver this application. So initial workaround they will do, they will check how much or how large this product is, and they will get into agreement that we will develop it in Agile. This XYZ company may sign up contract with this product management. Let's say product management belongs to Amazon. Okay, they will have contract between this XYZ company, and this XYZ company will say to Amazon, we'll go with Agile, and there is no fixed deliverable time, but as soon as you give requirements, we will deliver that requirements in Agile. In Agile, we will take each module. If it is in small in size, we will deliver it in each sprint by sprint. Okay, in sprint 1 we will deliver module 1. In sprint 2, we will deliver module 2, module 3, like that we will plan, and each module by module we can deliver it to you. So in each sprint, we will deliver one module. That is how we are planning it. So you give requirements for that module 1 completely, we will deliver it. So before we delivering it module 1, etc. So you give module 1 requirements, we will start it and we will deliver it, and then you can give us the requirements of module 2, module 3, like that. One by one we will go and deliver it. And then immediately Amazon may ask, can I use that module? If you deliver, can I use it without other modules? Yes, if your module is not having any dependency of other modules, you can make it useful. You can make it useful. Okay. Let's say in this complete product management system, first I wanted to create users. I have a lot of warehouses. In warehouses, I have a lot of managers. They will manage the products. First, I want to create that managers into the system. I want to hire them. I want to give the background of this application. Okay. And I want to create that users into the system before getting application ready. I want to create users into the system. So in sprint 1 user management module, I can plan user management module. I can plan here user management. So Amazon will say, okay, go ahead and develop user management. Now this XYZ company, what they can do, this sprint 1 module 1, they can deliver it as a microservice. They can design this application. They can design this application and deliver it. They can design this application as an application. This user management as an application, like user management service, as an application, user management service as an application or a microservice. You can say you can deliver it. You can deliver this user management so that as a business Amazon can start test it. They can start real testing. Once you deploy it, they can start real testing. And here the advantage here, parallelly, if you want to start with the next module also, let's say they want to deliver it as soon as possible, and if they say go ahead with other modules also and parallelly design and deliver them. So multiple teams parallelly they can work here. Let's say the sprint 1 is going on, maybe few team members can work here, or you can divide this into multiple projects. You can divide into multiple projects here on one sprint. Let's say sprint A is happening here, user management, one team is working here, team A team A is working here. They can continue with this module 1 and they can deliver it parallelly. If you have multiple teams, team B also can start work on this module and they can deliver it in the meantime. So parallelly multiple teams can work here if you make this application as a microservice. If you have multiple teams, they can parallelly work on them. Let's say if you have only two teams can work on two modules, excuse me, and they can deliver. So when this can happen independently, teams can work if these modules are not having any interdependencies. If these modules are not having any interdependencies, let's say module 1 is having dependency of, or module 2 is having dependency of module 1, then this module definitely need to wait for the module 1 deliverables, then it can start here. But usually in microservices, what we do strictly, we don't recommend to put any dependencies between modules. That's how we divide requirements. So if you have a lot of dependencies between two modules, instead of developing them as a two microservices, we will develop it as a single microservice. So we don't put so much dependencies between modules in microservices. So here, what is the advantage if I go with this model? If you see, lot of advantages we have, lot of advantages we have. First thing, parallelly multiple teams can work on them and they can deliver it. So from the business point of view, if you see, he need not to wait for until next to 12 months. Let's say same efforts will take here. But parallelly five teams work. If parallelly five teams work, 12 months of time or 15 months of time, 15 months by five teams if they work, five teams if they work, they may deliver it in 3 months. They may deliver it in 3 months. The complete product they may deliver it in 3 months. Usually it is taking 15 months of time. So what is the advantage? If they wait for 15 months also they can get the product. Why they need to get it in 3 months? As I'm investing 10 crore rupees here, let's say if you brought this 10 crore for the business loan, okay, so by this 15 months of time they need to pay all the interest, everything, and within this 15 months of time their idea maybe go up, out of or not up to date product. Okay, so this product may, what we call, become a old product or old thoughts or old ideas which you thought of 15 months before, maybe not up to date to the current market. So if I think something, if I can able to deliver it in next to 3 months, okay, it will be fresh idea so that I can market it. Generally, they will have lot of strategies. If somebody designing an application means behind the application they will have lot of strategies. So I thought of a strategy to boost up my business, and I brought this idea for the application development. But if this idea is going to take next 15 months, maybe somebody else also can thought of it, or during discussion if I discuss it with my team they may share this idea with other teams or other counter partners or other counter companies. They may start doing it and they can bring the same idea into the market, so they can grab the business. Okay, if you see from the business angle, once if they thought of a application with a good strategy, as soon as if we can deliver that application, okay, that thoughts will be up to date and they can get the good business. If it is going to take long time, they may not able to market it, or they may not able to get the business as they expected. So definitely here the client will benefit with this microservice applications. From the business side, if you see, within very less time we can deliver the application, as we have advantage of parallelly multiple teams can work on it. Not only that, lot of features we have. Just from the business side, this is the great advantage that we have. Apart from that, apart from that, that is the great deal to them. If we can deliver it in 3 months, that will be great to them, so that they can market it and they can bring the application up to speed into the market and they can grab the good business. Now, coming to this vendor side, whoever is developing this application, they have lot of advantages. First, client is having advantage. Then this XYZ company also is having lot of advantages. What are they? I have 3 months of time. Within 3 months of time, I want to deliver this application. Within 3 months of time, I want to deliver this application. And this Amazon is having no problem with the technology. They are okay with Java or .NET or any other Python, whatever you want to choose, you can choose and you can deliver it. Now this XYZ company is having multiple teams. Two Java teams they have, and two .NET teams they have, and two Python teams they have. Now this XYZ company decided to develop this application in microservices. What they can do, there are ideally two Java teams or two .NET, two Python teams are there in their company. They are in bench or they are ideal. So they want to utilize them to develop this application. They want to utilize them. Or else let's say they don't have employees, but in market they can able to found a lot of Java, .NET and Python people, and they don't want to invest only on Java, or they don't want to invest only on .NET or Python. They want to hire multiple technology people so that after this application they can utilize them for multiple different businesses. So they want to deliver this application in different technologies, not only in Java. They want to deliver this application in multiple technologies. They can do that here. As microservices, always in microservices, always we use web services concept so that in case if module 1 is having dependency of module 2 or module 3, irrespective of technologies they can able to talk to each other. Irrespective of technology they can able to talk each other. If you design your application in REST based or SOAP based in web services, microservices, indirectly we use here web services concept. Here we use web services concept. Here we use web services concept here. Web services, particularly REST based web services we use here. REST based web services we use here, so that whatever module you implement, that module can be invoked from other module irrespective of technology. Let's say module 1 is designed by this Java team. You have two Java teams, two .NET teams, two Python teams. So I can deploy one Java team here. I can deploy one Java team. I can deploy one Java team, Java team 1 or team A, work on sprint 1, which is having user management module. Parallelly, other Java team, they can work on the next module. Other Java team, they can work on the next module, team 2, and they can deliver the same thing. Module 2, let's say multimedia management, or next product management, creation of product management module they want to design, so they can start design and they can deliver it. And parallelly, other .NET teams, if they have web services concept, every technology is having this concept, so they can work on this module 3, they can work on this module 3, they can work on this module 3. Let's say multimedia management service, they want to design it in .NET, they can work on it parallelly. And there is a Python team, they are also having the capability of designing it and deliver it REST based service. So they decided to develop it in Python, some data management, some data reading and data writing. There is a module, okay, maybe what I can say, publish module something, publish into e-commerce. So this I want to develop it in Python, so they can work on it. So parallelly, you can start work on each module with the different teams. Parallelly, multiple teams can work on it irrespective of technologies. So multiple technologies they can use. As a company, I have multiple advantages here. I need not to hire the same technology people. Let's say Java people are very costly. I want to go with .NET. The same expertise I will get in the .NET. Maybe for one resource, one instead of one Java resource, I'll be getting two .NET resources. Okay, so and they can deliver as much as fast like Java and Python people. So I want to develop few modules in the .NET so that I can save the budget as well. Okay, I have a lot of strategies as a vendor. I want to save a lot of money. Okay, I want to save a lot of money, so I can play strategy here to reduce the burden of investment on this application development or developers or teams. So parallel I can use multiple technologies here to deliver this application, and parallel these teams also can work independently they can work and they can deliver it. As these modules all are designing in web services, Microservices are nothing but web services. We use web services REST concepts only during implementation. They can talk each other. They can talk each other. You can see the same here. UI is talking with microservice, and one microservice is talking with another microservice. If you see, between microservice to microservice also we can have calls. If it is in REST, anybody can call, not only Java. You designed it in Java, anybody can invoke it. Anybody can invoke it. So you can get calls from maybe .NET, you can get calls from maybe Python, you may get it from Node.js application. Any application can make calls to you and you can respond. So we will have a common, medium to exchange the information between modules via REST HTTP protocol. So that is a common protocol for any technology. So they can understand what you are sending, or easily we can understand what they are giving to us as a input. Okay. So I can see from this company side also many advantages. Parallelly, I can deploy different teams in different technologies. So the technology dependency also we will get here. Technology dependence in the sense uh, independence. Here as a technology we will have a lot of independency. If you design your application into microservice, different technologies I can use here to deliver this application. Depends on the requirements. Let's say this user management module, it is good in developing Java, so I can choose Java. And something publishing into e-commerce or data management or data read writes, lot of such data operations I have, maybe Java is not suitable to me, I may go with Python there. It may handle better. If I feel if it handle better than that, I can utilize it. So I need not to depend on any particular technology as well here. So this is from the vendor side. Then what are all the advantages that we have from the team side? As a team, we are developing this application. What are all the advantages that we have here as a team? So here client is having benefit, vendor is having benefit, and as a team or team A, B, C, whatever it is, you also having lot of advantages here when you go with microservices. When you go with microservices, right? You are independent to work here. So independently they can work. So no dependency, no direct dependency on other modules. So independently we can work and deliver the requirements. Independently we can work and deliver the requirements. So I picked a module, that particular module only I can develop and I can deliver it. So you should avoid, if there is any dependency, right? Slightly we will have, but we should avoid as much as dependencies in the application during design itself, or as an architect you need to identify all such dependencies and you should try to avoid it. You should try to avoid it as a small team. As a small team, teams will be small here because you will have very small requirements only. So as a small team, it is easy to manage team also. It is easy to manage team here, easy to manage team. And maybe we need to sometimes work cross functional, sometimes not all the time. Sometimes you may need to meet team B people or team C people to understand other module requirements. If you have any dependencies, in case if you have any dependencies, you may need to work with other team as well. Maybe that will happen when you have dependencies between modules. So as a crash functional team, you should be working, or you should be connecting with other teams as well to understand their requirements as well. And easy to manage team, easy to test your product, easy to test your product. And in microservices, lot of tools given to us, easy to explain, easy to explain your API as well, easy to explain your API, how you implement it. Okay, easy to manage and easy to develop, easy to develop small requirements, right? It is easy to develop small requirements as an application, and it is easy to test as you don't have any other dependencies, and easy to explain API with other teams. Let's say you want to exchange this application with the other team members, or you want to exchange this application with the front end teams. It is easy to explain what's happening to you within your application via Swagger kind of APIs. We will talk about them. Okay. So team side also we have a lot of advantages. Team side also we have lot of advantages here. So they can easily able to manage this application, and they can deliver it. They can able to deliver it. And the deployment also becomes simple here. Deployment becomes simple here. Deployment is easy to deploy via CI/CD and the cloud. So lot of advantages we will get from the cloud and DevOps. Cloud and DevOps, lot of advantages we will get here. Lot of advantages we will get here in microservices. Microservices application usually deployed by using CI/CD pipelines automatically into your cloud infrastructure. Because here, whatever size you need in the cloud, generally in cloud, whatever we use for that use only we pay, right? So you can get small amount of size in the cloud machine, small RAM, or you know maybe a virtual box or a Linux or EC2 machine, whatever you take, a small in size machine is sufficient for you to deploy and test your application. So it is easy to deploy. You need not to make it a jar file, and you need not to do any physical deployments where CI/CDs usually we deploy our application, which means just you need to push your code to Git or Bitbucket. From there, CI/CD will take care of deployment. So you need not to worry about deployment also. And cloud also giving lot of infrastructure support to reduce the or not only reduce, to maintain the application easily. Lot of tools also will be provided from the cloud. All the cloud advantages we can take here in the microservices development. And maintenance of this application also easy. Maintenance of application is also easy because your application itself small in size, and we are taking advantages of cloud. There will be lot of tools to monitor your product, so we can easily monitor and we can understand what's happening with our application. If there are any downtime, generally in cloud there will be no downtime. Lot of failure handlers we will have. So if application is going to down, we will have other nodes, and that nodes will continuously work on it. Load balancing, lot of maintenance side benefits we have here. Load balancing is easy. And maintenance in terms not only load balancing, there are many, right? So configuration management is easy here. Configuration management for your application, and load balancing, lot of advantages from maintenance side. Logging, monitoring will be simple here. Lot of benefits from the maintenance point of view also we have here. If we go with the microservices, then why we should develop application in monolithic architecture? Okay. So in monolithic architecture, we have a lot of dependency and only one technology we need to use here. If you go back and see here, right? So here in monolithic architecture, I have a lot of modules, and all these modules I want to develop it in a single application. Single application means I'll take Eclipse, and in Eclipse I'll create one project. In that single project itself, I'll be having all the modules. I'll be having all the modules. So I can't use different technologies, as project itself is a single project, or maybe multiple modules project you have, but you want to develop it in Java. If you choose it in Java, only Java you need to use to develop this application. Other technology people you can't involve here. Other technology people you can't involve here, like in microservices. In monolithic you can't use different technologies, but in microservices we can use lot of teams parallelly. They can work and they can deliver testing, deployment, maintenance. Everything is easy, and we can get the benefits of cloud as well here. Okay, so what else we need from the market? So now you can deliver your application up to the mark within very less time, and you can use a lot of cloud advantages as well. That's a reason. That's the reason every application is shifting towards the microservices. Every application moving towards the microservices rather than monolithic. It is benefiting clients, vendors, teams, everybody. So that's the reason we all moving towards the microservices. Okay. Yeah. So we will see one by one. Okay. For microservices, what are all features so given from Spring Boot or Spring Cloud? Okay, one by one each topic will pick, and I'll explain you, and I'll make you comfortable in microservices thought process itself. Okay, just we need to change our thoughts from monolithic sites to microservice. That's it. Application development is simple again here. Okay, so yeah, I'll explain each feature, how it is advantages us here in microservice. Okay, and we'll carry forward that. Yeah, we will discuss batch, transactions, AOP. Okay, don't worry.